Hello, everybody. Today we wanted to show you how draw undrawable by using our custom render box. But firstly, who we are. I'm Victoria Sobczak. I'm a Flutter developer and I'm working for HDD team.
Yeah, I'm also working for HDD team in Poland. As you may guess, I'm the Flutter developer too. What a coincidence. And yeah, in this presentation, we'll talk about the RenderBox, the difference between RenderBox, render object, what it exactly is, the layout protocol, the paint protocol, something about the heat tests, and the semantics, of course, as this is also a very important topic. And we will wrap all this together into a case study, and we will cover this step by step in the...
So we will have our case study today. So imagine that we have a button to do as a developer. So it's quite simple, right? But what about when we have some minor changes from our UI UX designer? For example, different shape, different layout. So we should think about some changes. So Camille, how to implement it?
Yeah, sure. It's a very interesting question. So first, the first thing we can do is to look at the designs, look at the button. For example, here we can see the hexagonal button. It seems very simple, but maybe it is not. So the first thing we can do is to go to pubdev, for example, any other package repositories, and look for things that may interest us, because there may be a package that solves our issue. Or we can use, for example, a clipper. Maybe you can use a normal button, default button, so for example, a weight button, and just clip the corners and that will work for us. Or maybe we can use Painter. So for example, if you want to draw like some type of image or marker or something like that on the map, the Painter could be a good decision. And there's the fourth option, and this is the RenderBox. But what is RenderBox? To know more about RenderBox and what it is, we need to do one step back and think about Flutter, that Flutter has the three trees. And this is the widget tree that we all know, because this is the tree that we're probably working on our daily basis. And also there's an element tree that is basically the life cycle of our elements. It's like the Flutter managing the widgets and render boxes and things related to them. And there's also the render objects tree. And this is the most important, most interesting for this presentation, a tree. And yeah, and let's imagine that we're creating a widget. For example, this is a padding widget. And because we are creating the padding widget, Flutter also creates the element for them. And the render object is created by this element. And the same works for its child. So we're creating the text child, the element for text is created, and the object, and so on and so on. This is the simplified version of this, like I say, tutorial about the trees. And yeah, and the render object basically renders the widget. So the widget is like some type of configuration for the widget. We can think of this about the widget in this way. And yeah, and the render box is basically a specific type of the render object. So render object is like something basic, like the basic class for rendering things. And we can think of it like it can render like cactus, like flower, like many multiple different things, like render anything, right? And there is also a render box, the topic of this presentation. And this basically means that, yeah, this is box. We would like to render box. So something in two-dimensional space like X and Y. So this is the render box. And it has the protocols that I mentioned before. So layout, paint, heat test, and so on. This is the basic, like the core concept, core protocol that we will cover slightly in this presentation. And yeah, and we can assume that everything that is basically visible on the screen is a render box. So yeah, maybe everything the Flutter is widget, but everything that is visible on the screen is a render box, because render box is responsible for rendering things. And yeah, so we can guess that this is the native way of rendering things in Flutter. So Victoria, should I create render box every time?
Unfortunately, the answer is mostly no. When we should choose the render box, when we have really undrawable tasks to do, for example, widgets are not enough, and when we wanted to improve performance, optimization is required. But we should know some few things before we wanted to implement our render box. It's really hard to debug. I mentioned earlier about this is quite a more performant than for example, some widgets. But when we add some bug there, it will be really hard to debug when we have our bug in our code. And it's a lot of new concept to learn. For example, a lot of maths there, and some graphic programming concept to learn. And this is really time consuming. But in our case, clip path will fit perfectly, so we not need to use RenderBox. Thank you for your attention. So let's imagine that uh, our RenderBox is the best solution because we wanted to show the basics concept and show you how to start and implement all these things uh, based on this our case study. So, how to start? Firstly, we should take a look at the design. Yeah, we have our hexagonal button, but sometimes we should think about some generic solution to cover most things from our graphic designer or UI UX designer, and consider to create some generic solution. So as we can see, we have some child inside and some different shape. And we should cover these things before we starting implementation because it's really that I mentioned earlier. It's really time consuming, so it will be easier for us to think about this earlier before implementation. So as we can see, we have a button that have some child inside. For our case, we have right now only text, but we can have inside, for example, image and another child. So let's think about properties list. As I've mentioned, child will be generic because we don't only support the text inside in our button. So we add the child property, and we can think about add the padding because we wanted to um, change it and, for example, manage how a lot of space will be have. And as we can see, color is sometimes really important, so we add the color property. And yeah, we add it, and as we can see, our child cover our parent area, so it's not looks like the best. So we add some property that we um, provide as clip size, that this is the size that um, show our children to not occupy area for our parents. So this is our clip size parameter. And of course, this is our button. So we should think about on top method to add some interaction from user. So why is it important to think about all scenarios or variation of our button? Because there are some decisions to be made before our implementation to think about how our render box should looks like. So as we can see, we wanted to use our render box as a widget. So finally, in our presentation, we wanted to use our render box as a typical button. For our presentation, it will be hexagonal button. So yeah, we have some render object widgets that the render object widgets return our render box and allow to use our render box as a widget. And as we can see, we have some types of render object widget. Firstly, we have a leaf render object widget that don't have any children. For example, text and similar way. And we have a multi-child render object widget. This is the single list of children. For example, row or column. This is really important on layouting stuff. And as we can see, we can have a single child render object widget for one child. For example, padding or center widget in our situation. And there is even more types of render object widget. So we can go to, for example, to our core Flutter framework, and when you want to implement our custom render box, we can check how our main framework widgets that we are using on each day in our current work, we should check it, and it will be easier for us. For our case study, we will chose a single child render object widget because we have one widget and we wanted to manage them to manage him to um, manage position. And as we can see, we have some type of render box because we don't want it to reuse our reinvent our wheel once again. So we can check what type of render box should I use. And we have some types of render box. For example, render proxy box. This is the simplest mimic the child properties. We have a render shift box that allow us to control the position on our child. And we have render stack. It will be helpful for children that is position of each other. And we have a render paragraph for render paragraphs. We have platform view render box. It's for embedding from view. And we have many more that I've mentioned earlier. We can check in our core code and check what we can do, what we can choose to our render box when we are implement our own render box. So for our example, we will use render shift box. And let's start to implementation with our render box that I've mentioned earlier. We chose render shift box because we wanted to position our child inside our button. So firstly, we add some custom properties. Firstly, we add the color. We have one method, marks needs paint, that I will more deep dive and describe it later. And we assign it and our constructor. And we add our clip size property, and we have a similar that we have with our color property, but we have one slight difference because when we wanted to change only color, we only mark our render box that needs to repaint. And for our clip size, we mark it like we should change our layout. And after invoke this method, we don't need to mark needs paint because it will be invoked automatically after a method that mark needs layout. So this is the difference. And we add also padding property. It's similar because we're changing our layout stuff. So we have similar example to clip size. And we will still missing one more property. It's the on top. It's really important to our button. And we have one important thing here that I will describe later. This is mark needs semantics update. I will take more deep dive on this thing later in our presentation. So how to provide these properties to our render object? So we need to create a widget. Okay, so as we can see, we have our hexagonal button. We chose single child render object widget, and we have similar parameters that we have in our stateless or stateful widget. And so we define it in a typical way. And also we need to implement two methods. It's for creating and updating our render object. First one, it's similar to our factory method. It will be invoking when we creating our render object, render box, and we can similar solution that we have in our constructor method. And as we can see, we have updating render object method. We update the properties. This method will be invoked automatically when our each property will be updated. Okay, and that's all. Also, we should think about override this method that debug field properties. it will be really important when we wanted to debug our custom render box. And from now, we can use our hexagonal button widget, and yeah, as our typical widget. But let's take a look to our telephone, and it's like we don't have anything. So, Camille.
Yeah, thank you, Victoria. That was really intense. Yeah, so as you can see, we have like 200 lines of code or maybe more, and still like that's what we get. So we have nothing but 200 lines of code. So RenderBox is really complicated. There are a lot of things that we should do to support it, to implement it in the correct way. And this is not even the beginning, right? This is like defining only the values, the properties that we will be using in the future. So yeah, let's dive into the layout. And layout is basically a protocol that's work for like defining the size of the elements and the positioning them. So for example, if you have a square, we want to put this square into, for example, left bottom corner with the size of 50 pixels, for example. And yeah, so let's back to the render box. And this is the render box that Victoria described in a moment. And yeah, and there are two core methods that we should implement here. So for layouting, there is a perform layout method, which is method for basically layouting our children, so defining its size and the position of a child. And the compute dry layout method, which also is responsible for calculating the size of the render box, but this with a slight difference, because this is the dry layout method. So this method is calculating the size for this render box, but without setting the values to this render box. So this method is basically like some type of helper method we can think of that is computing the size of this element without basically setting this for this widget. And yeah, so for both examples, for both methods, as you may think, we need to define the size calculation. And the size calculation will be very similar for both methods. So the simplest thing that we can do is to define one single method. I know there are a lot of maths here, but let's focus on these parts, like the parameters for these methods, for these helper methods, is the box constraints and the layout child method. Layout child method is basically the method that accepts the child and its constraints, basically the constraints that this child can take. And we will talk about the implementation of this method in a moment, but basically this is the most important thing in this place. But yeah, as you can see, there is a box constraints and we're returning the constraints, the size. So let's take a look at what exactly this is. So box constraint is nothing more than min width, max width, min height, and max height. So this is basically the definition of the minimum and maximum size of the render box. So it is like we saying, hey, our child, you can be that small or that big, yeah? So this is like the square could be that small or that big. This is basically all. And what child gives us is give us its width and the height. This is the exact side that the child would like to take. Yeah. So this is like the answer that okay, I take this width and this height from the available constraints. And the layout process is like parents is sending constraint to its children, this children sending to its children, the leaf children sending the size back down to the tree, and this is basically all. Like the tips for that are almost everywhere. So you can take your Mac and just think of this in this way also. And yeah, backing this method. So we can see here, the thing that I would like also to point is that we do not like reinvent the wheel. So we're using the methods that are built into box constraints and so on. So basically this is important that, for example, the constraints has the method deflate that can decrease the size of the box constraint by the provided instance. So for example, we defining the padding and the clip inset. So this is the space, the horizontal space that we would like to be clipped to the hexagonal shape. So we are providing this instance, and the constraints will be decreased will be decreased. And yeah, thanks to that, our child will be much more smaller than the parent. And yeah, and the last method here is the constraint. And this is basically, we are providing the target size, the size that we would like to take. And this helper method returns the closest size possible in these constraints. So yeah, this is like the implementation. The maths might differ for, the maths basically will be differ for any type of shapes, for different render boxes. So there's nothing important here really. But the important thing is that in compute size method, here we are providing the constraint for the arguments. So the constraints provided to us from the parents, so the size that we could take. And in the layout child, there's a difference in layouting. So the child also, from the child, we are also getting the dry layout method. So basically, the computed size for the compute dry layout method of the child, and next to that we have the size calculated and the compute dry returned. And there's a difference for perform layout, because in the perform layout we are using the child layout method, and as you can see there is no constraint argument, so we're using the constraint that is basically the property on our render box. So the constraint is set, and this is the value that we would like to use, and we are setting also that parent uses size. So basically after this layouting text to that argument, we are able to do like child.size and read this size. So these methods are really similar, but there is a difference in layouting. And also, like any render box can have child, or there is a chance that the child will be not present, so we should also think of it. And here, if child is present, we are reading the parent data for a child, and as we will set the position for the child. So we would like our child to be centered. So we are also using the alignment center and the helper method. This is along offset. So this basically will return the offset that is required for our child to take the place in the center of the parent widget area, in the render box area, based on the difference on the size difference. Yeah. And a lot of code and still nothing visible on the screen. So yeah, great thing.
So finally, we have a paint method that maybe we can see something finally. Okay, so let's go back to our RenderBox code. And that's why we should do in this step. We should override the paint method. And as we can see, we have a path. We have a helper method get border path that describe our shape of our button, and in the another shift path variable, we just only shift our path by using our offset that we have from our parent widget. Let's take a look for our get border path. This is the typical path that create our hexagonal button shape, and only that's it. It will be different for our different render box size. So this is some kind of typical, and we define this path method. And finally, we can draw something on Canva, and as we can see, we add our shift path and paint. Invoke our paint method, and on our shape we fill it and take the color that we have from our properties list. And as we can see, we have finally something visible in our phone, but it's only a shape, and one thing are still missing. We don't have any child rendered. So to render our child, we only can invoke our super paint method. That's the simplest way to render our child. We can take a look on this method that we have, this kind of code to render our child. And this is the easiest way that we can render our child with the offset. So that's all for our paint method. Finally, we can see our button and text widget inside. So, Kamil.
Yeah, but that's not all. Like, we have our widget, we have our render box visible to the screen. So like only the 15 or 14 lines of code is basically drawing our simple button here, but there were many more work during the layout. And there is also heat tests to do. So heat tests basically are the mechanism for determining whether the position is included in our widget, in our render box. So we can imagine that this square is basically our render object, and this is the event, the position, the finger on the surface of our smartphone. And yeah, and we should mark this position as it is not included into our render box. So this is like the miss. So this is a heat, this is a miss, and this is the heat. And this things is much more complicated for different shapes. So for example, for our hexagonal button, the corners should be marked as missed also. So there are so heat test is also very important in this scenario, and we should think about it. But yeah, there are two methods for heat test, and there is one core method. Like I can say there is heat test method that is basically in default implementation invoking the heat test children and heat test self method, and these names are basically self-descriptive. So heat test children basically checking whether the children were hit by the position, by the heat, by the event, and the same for the heat test self, which is only about our widget. But for our scenario, heat test, the default method heat test will work perfectly. There's no need to implementing all of this method. So we can only add like simple check, and I will use here the same method that Victoria used to draw this this button, because this border is basically the thing that is visible on the screen. Yeah. So we want our user to be able only to hit the part of the button that is really visible on the screen. So the border, we are taking the border, and basically there is a simple method contains that will check whether the position is inside the path or outside. So if the position is outside the path, there is no need for invoking the heat test, for invoking the on-tap methods, on-press, and so on, because as you may guess, the position was outside. And the simplest way to do is also use the super heat test method, because the default implementation will just mark that this heat test will hit, and we'll add our heat test entry to the box results test results. So this is like the simplest way, and still a lot of code to do. And yeah, there things can be really optimized here, because the get border path, for example, can be cached in the render box, because render box is not removed from the tree every build like the widget is. Yeah. And now we can correctly receive and handle events, because every time the user is pressing a button or moving a finger or something like that, the event will the handle event method will be fired with this event. But like this, that's still not everything, because these are not gestures. This is only the event. So this is the raw information that the pointer is down on the screen or pointer is moving. But the gesture basically combines the raw events and transform it to the gesture. So, for example, drag is like pointer down and pointer move into one direction. So yeah, we need to calculate this. And we can use for this, for example, tap gesture recognizer. But yeah, like this is the best place for it is to use the stateful widget. So we can use stateful widget for that and define tap gesture recognizer there. And what is important in this example is that basically this is not the code that you would like to use in your production environment, because mostly in production environment, it is good to have widget composition. If, for example, have the listener widget or gesture detector widget that will listen for this, no need to do it one more time in your way, because this will cost you a lot of time, and this may could provide many bugs. But yeah, but this is only for purposes is to show you how this really works and how the event flows from the render box to the tap gesture recognizer. So as you can see, here we are providing the on-tap method, which is basically method that we would like to provide us like on-pressed to our button, and the on-pointer down that basically is a method that will provide the events from the render box to our gesture recognizer. And to handle that, we'll add the on-pointer down property to our widget, to our render box. And yeah, and in handle event, if event is a pointer down event, we then provide this event to our gesture recognizer. And the gesture recognizer will receive it, will analyze it, and if this is an on-tap callback will be called, and something awesome will happen. So this works like that, and this is like the flow. So if you think about the raw gestures, gesture detector, for example, it also uses the widget composition. It is use listener widget for that purpose. So it's also sometimes a very good idea to use widget composition to define a button, because as we now defining the hit test, defining the on tap gestures, defining the pointers that are moving, event pointers that are moving to the tap gesture recognizer, there is still no feedback for user. So we also should think about the feedback like inkwell, opacity, or something like that when user is tapping the button. So there is another much more work to do to support that. And yeah, basically that's all for hit test. This is like the concept of it, how this work. For reference, I really would like to recommend the official documentation. It is really good, and there is also very good examples of how it is work and how you can use it.
Okay, so our button still looks the same, and until it doesn't. We have really important thing and topic. This is about our, because we are all different. Somebody from us maybe can be blind and using our voice recognizer to using our apps. So we have a really important topic that it's sometimes skipped in our project. And as we can see, accessibility is very important. We can do some experiment in your phone. You can enable accessibility and phone reader to your app, and just don't think about maybe see documentation how to use it. And for us, it was a big experiment, because for me it was really hard to open and manage the gestures, and it was really weird for me. And it was the experiment for me that I'm blind and I don't know how to use my phone, and it was really weird for me how to use it. So we can think about accessibility, and we can check on our own site how to use our phone without eyes. Okay, so let's take back to our RenderBox code. And to add semantics, we override one method. This is describe semantic configuration. For our case, we only define a label that will be called after reader will be told us our text inside the button, and later told us the hexagonal shape button. And when we provide this is button flag to true, our, for example, Android recognizer can talk to us and mention that this is the button. The most important thing that we have here, this is the on tap method, because it wouldn't be invoked by our gesture. It will be invoked to our phone reader, and it will be called by gesture, and not by gesture, but only a double tap on our phone. No matter which kind of point, we just double tap. When we have enable accessibility in our phone, our phone reader just invoke by our on tap. So this is the most important thing. And when we wanted to check more semantics configuration, I really recommend check the semantics config object, because we have a lot of properties that we can override. And let's go to our summary section.
Okay, so yeah, in Flutter, everything is not just a widget. So as you see in this presentation, everything that is visible on the screen is a render object, and we need to know that, and we need to be aware of that. And the RenderBox is a powerful tool. So yeah, so you can do basically anything thanks to the RenderBox. You can define your own gestures, you can draw custom shapes, or or I don't even know. So basically you can do everything. But as you also see, there is lots of code. In this presentation, because we have only 40 minutes, not the infinite time, we were using only the like the simplest way of doing things. So like the super methods, the helper methods from alignment, and so on and so on. In case if you want to define it all by your hand, the code will be very, very long. And it's very complicated because this is not like defining the widgets, the putting padding inside the container and so on. There is much more work to be done here. And this is like UI coding. So like the graphic coding. So you're also doing the heat test, also doing the drawing point by point things. So much more complicated. And yeah, in most cases, you don't need to use it. If you can use widget, just go for widget. If you have problem with performance, if you need to optimize things, if you need to draw things that are not possible to draw with your widget composition, this is the way to go. But do not use it when there is no need for that. Layout, painting, heat test, semantics, this is the essential, right? This is the protocols that you need to know to start your journey into RenderBox world. And yeah, the very popular question is that they are single frame. So when you think about the animation that you would like to do in the thanks by the render boxes, this is just providing many multiple different values over time to your render box, and render box is only drawing a single frame. So this is also very important that animations are not done in the render object. Animation is like values are changing. Your stateful widget are provided to render box. And with RenderBox, you can create great things. This is the example of a gauge indicator that we did in our application a few months ago. So as you can see, this is maybe not the easiest thing to achieve with only a simple widget composition, like many custom painting. And also the size of this widget is changing when the degree of this gauge is changing. So yeah, there's a lot of mathematics underneath.
Okay, and we have here our QR code. We have some materials that will be helpful for when you're maybe wanted to learn something. And we have a lot of information that we include in our presentation. We have a link to our presentation, and we have a code there. So when you wanted to check on your own, you can go to this link and everything would be inside there. Okay, so I think that's all from our side. Thank you for your attention, and I think we can go to our Q&A maybe.